Everyone, today we're going to be looking at the square root function, or the graph of y equals the square root of x. Now when it comes to the graph itself, we ignore the negative part of our plus or minus, okay, and we only deal with the positive under the square root sign. Okay, so if I had the square root of 4, we're only going to deal with positive 2 in that case. What this means is that our domain can't be a negative under the square root sign for just a regular square root graph. So that means I've got a domain of positive real numbers, including 0, and the same can be said about my domain. Now, once again, this can change with transformations and that sort of thing. What you'll see with the square root graph is it is just a reflection of a parabola, so just a regular y equals x squared that's been reflected in the line y equals x. And they're called inverse functions, which you'll learn about a bit later on in this course. The endpoint of this graph, if it hasn't been moved or anything, is going to occur at 0, 0, and that's because we cannot go below 0. All right, so some key points are going to be things like 0, 0, 1, 1, 4, 2, 9, 3, etc. Okay, and you'll see it has that curve, just like a parabola does. All right. This can once again obviously be changed with things like dilations, reflections, etc., which we're going to go through as well. Now, reflections and dilations follow the same rule as they do with every other graph. Okay, if I've got a negative on the outside of the function, this means that it's being reflected in the x-axis. Okay, so that 0.11, if I take the negative of that, is going to be 1, negative 1. I'd end up with 4, negative 2, etc. Okay, but our endpoint in this case is still going to be at 0, 0 because we haven't moved it. Our domain itself is still in the positives, but our range now is in the negatives. Okay, for this next one here, because the x is the one with the negative, we are reflecting in the y-axis. Okay, so that 1, 1 is going to become negative 1, 1, negative 4, 2, and so on. And that means that the domain for our x is the one that's changing. Because we have to keep it positive under the square root, I have to multiply that negative by another negative. Okay, whereas our range is going to remain untouched. It's going to be all our positives, including 0, with an endpoint at 0, 0. Now, if I have a negative both inside the square root and on the outside, we're going to be reflecting this in both our axes, okay? So that means that our graph's going to end up looking like this, with this being negative 4, negative 2, negative 1, negative 1, and so on, okay? Our domain is going to be all our negatives again, because we need to make it positive under the square root, and our range is also going to be all our negatives. Now, when I talk about this domain and range, something to keep in mind is this is called an implied domain. Okay, so if it hasn't been specified, then you're going to specify it and say, well, this is what the domain has to be in order for this graph to work. That's an implied domain. Now, this one here, we've got the 3 on the outside. Pardon me. So it's a dilation of 3 from the x-axis. Okay, so that means this 1, 1 is going to become 1, 3, and that 4, 2 would become 4, 6, etc. Okay, and that's just because we're multiplying all our values by 3. Now, our domain and range, once again, with a dilation, remain untouched from the original. Okay, it just means that this graph is going to be climbing a bit faster, with our endpoint still being at 0, 0. Now, when it comes to translation, that's when things change a little bit. Okay, so this one here, you can see it's been reflected in the y-axis, but it's also been moved 2 units in the positive y direction. Okay, remembering that we follow the order of DRT in this case. Okay, so we're reflecting it in the y-axis, but we're going to be moving all our units up 2. Okay, so what would have been negative 4, 2 is going to become negative 4, 4, and our new endpoint is going to occur at 0, 2, okay? Our domain in this case is going to be all our negative numbers, including 0, and our range now just goes from 2 to infinity instead, because it's going to keep climbing up, all right? This one here, we've had a translation of 2 units in the positive x, and 1 unit in positive y. So that's just shifting my endpoint from 0, 0 to 2, 1. So all my points now are going to move across 2 and up 1. Okay, so now this one's going to become 6, 3 instead of 4, 2, and this endpoint here is going to occur at 2, 1. So our domain is going to be from 2 to infinity, and our range is going to be from 1 through to infinity, okay? So if we have a translation or even a dilation, a reflection, so on, that has h and k in it, our endpoint is going to occur at hk, regardless of the dilation and reflection, okay? So to generalize that, our domain is going to be, if we don't have a reflection, is going to go from h through to infinity when a is greater than 0, and our range is going to go from k to infinity once again when our a is greater than 0, so when we haven't had any reflections of any kind occur. Okay,